Good morning, good afternoon, good evening, ladies and gentlemen. This is a sector of the Minamata Convention Secretariat, and I am very happy that all the panelists and speakers are online now. So we will start the session in 1 minute. Sorry for the panelists. I disappeared for a while. There's a WebEx problem on my end again. So
Can I just confirm that you're going to play the video rather than have me talking live?
Yes, yes.
Please. Okay. Good.
Yes, yes, we do so. Okay, so good evening, good afternoon, good morning, ladies and gentlemen. It is noon on Geneva time, so we would like to start. A very warm welcome to this Minamata online session, season 2. I see my video. I see some exclamation mark in my screen. So please let me know if there's any problem listening to my opening remarks. But anyhow, I will continue. So okay. So this is the second to last one of the Minamata online season 2 for this year, and we are planning for more sessions for next year. Minamata Online is the series of online events that we started last year, and season 2 this year consists of 3 streams. One is a Mercury Science stream that we the Minamata Convention Secretariat co-organized with the ICMGP International Conference on Mercury as a Global Pollutant. And this particular session on coal is also co-organized with the UNEP, a Global Mercury Partnership. This is the last session for this year, but for next year we are going to organize several sessions in connection with the workshops that will be held in ICMGP planned for July next year. And the second stream is the supporting implementation of the Minamata Convention, and we are going to have a session on national reporting on the 22nd of November, and we will plan further for that. The third stream is the preparation for COP4, the fourth conference of the parties, and we just did the first online session of the fourth meeting of the Conference of the Parties earlier this month, and we are set for a in-person session in March next year to be held in Bali, and we will also organize some preparatory sessions for this COP 4.2. And before going into the substance, I'd like to provide some the housekeeping remarks, notes, and Sharifu, please go to the next slide. And if you can look at the participant list and chat box by clicking on the icon, and also you will see the Q&A box that we are going to use for the Q&A sessions. The participants are automatically muted when they join, and we if you need to speak, you will need to wait for the host to unmute you. There may be time for oral questions when we do the panel discussion, but we would appreciate you put the written questions in the Q&A box and send it to the all the panelists so that we can prepare for responding to these questions as much as possible when we do the panel discussion. Lastly, please kindly note that this session is recorded and broadcasted. It is broadcasted by YouTube streaming. The recording of the sessions and presentation slides will be made available through on the Minamata Convention website. And next slide is today's program. I'm not going to introduce all the panelists, and I leave it to the moderator, Mr. Professor Asif Qureshi of Indian Institute of Technology in Hyderabad, and he is a member of the executive committee of the ICMGP 2022, and also a host for the next ICMGP meeting in 2026, I think, to be held in India. So, but before turning to Asif, I would like to turn to Joy to have another opening remark as ICMGP. Joy, please.
Okay, thank you. Thank you very much, Isaku, and good afternoon, everyone. And I can't believe that we're actually at our fifth session now already. I know we press for time, so I'm going to just go ahead with the introducing the next Mercury Conference, which is taking place in 2022 next year. And this is the executive committee. As you know, it's a virtual conference in 2022. So we've basically added more executive steer members, and that is the last row, and then the last one is still to be confirmed. Next slide, please. And so now we've basically had all these where we've had various calls online on the website for Mercury workshops for a Lifetime Achievement Award, the Emerging Researcher Award, and then also the call for special sessions, which are all closed now. Next slide. And that basically just takes us to work in progress. So this is really just an advert for the next face-to-face conference, which will happen in July 2024 in beautiful Cape Town, South Africa, where it was supposed to be this year. But because of COVID, obviously it's virtual in 2022. So this is all work in progress. So over to you, Isaku, and just also once again, thanks for everybody again for participating in this webinar. Thank you.
Thank you, Joy. So, because the time of for this webinar is only 90 minutes, and this is really full of content, I will not spend much time speaking myself, and I'm turning to Asif as a moderator to introduce the speakers and moderate the panel discussion. So, Asif, floor is yours.
Thank you, Isaku and Joy. So hello, everyone. We will start with the presentations, the seminars. Our first speaker, it is my pleasure to invite Dr. Leslie Sloss. Dr. Leslie Sloss is an expert on mercury emissions and effects, ash management, mine reclamation, legislation and control, and has written numerous reports on these topics. She is very active in the work of the International Center for Sustainable Carbon, and also runs the workshop series on mercury and mercury pollutant emissions from coal. She acts as a lead on the UNEP coal partnership area, providing guidance to delegations on implementation of the new Minamata Convention, and has helped manage full-scale demonstration projects in several countries. She is also managing a significant project on capacity building in Southeast Asia on behalf of the US Department of State. She acts as an expert on BSI, CA, and ISO standard working groups and works through the International Center for Sustainable Carbon, along with UNEP, GMOS, US EPA, and other agencies. Leslie is also a fellow of the Royal Society of Chemistry and on the board of the Royal Society of Chemistry Energy Sector Committee. She joined the ICSC after gaining a PhD from the University of London and has a BSc Honours from the Edinburgh University. So we will start with the presentation. Leslie is online. For the presentation, this would be a recording, but she is online and she will be available for the panel discussion. So let us start with the first presentation.
Sorry, Asif, is it just myself that cannot hear Leslie?
No, Sharifu, we don't hear the audio, so perhaps you will need to adjust the volume.
Good morning, good afternoon, and good evening. Today I'm very proud to be part of this session where we'll be reporting on real work to reduce emissions from the coal sector. This is a challenge. Coal is still the main source of electricity in many countries. So I'll briefly take you through the importance of coal as a source of mercury. I'll then touch upon what the recent decisions at COP26 mean for coal and how this might actually make mercury control from the sector more challenging. And then, as a primer for the next talks, I will emphasise the importance of data when determining how best to tackle mercury emissions in a specific region, such as Indonesia. Before I start, I wish to thank the US Department of State for their generous grant for this project work. Also, before I start, I'm obligated to remind you who I am and who I represent. I work for the International Centre for Sustainable Carbon. We used to be known as the International Energy Agency's Clean Coal Centre, but we recently badged and widened our remit. We now advise on the clean use of materials such as biomass and waste, as well as coal. Feel free to check out our website, where 99% of our materials are free to download. We run workshops and webinars and produce a weekly newsletter to let you know what's happening in the industry. I'll put a reminder at the end of this talk about our organisation and how to find us. Let's jump straight in and look at a figure from the excellent 2018 Global Mercury Assessment Report. This shows the importance of the most common sources of mercury in different regions of the world. If we zoom in on the dark blue colour, that is the emissions from coal. And so it's clear that emissions from the coal sector are dominant in regions such as East and Southeast Asia. And so that is where our current project work is targeted. Looking at these data, the first question that often comes to mind is, can we just get rid of the sector? Can't we just stop burning coal? And after COP26 in Glasgow earlier this month, yes, this is exactly where many countries are heading. Most of the commitments to stop using coal focus on no new coal, other than plants that are already approved or under construction. No new coal is a reasonable promise to make, as long as you currently have sufficient energy and you have an alternative source of electricity in mind, such as baseload renewables or batteries or whatever. But renewables are not quite ready to act as affordable baseload. Countries who agree to build no new coal plants must recognise that the coal plants they currently have are now even more important than they were before. If no new coal plants are built, then the existing plants become even more crucial to keep the lights on. And these older units are often significantly more dirty than the new plants which would have replaced them. This is a slide that I've shamelessly stolen from ISACU, which summarises the requirements for coal plants under Article 8 of the Convention. All new plants must build mercury control into their design, and this is great. And with the number of new coal plants declining rapidly now, we can tick this box off as achievable. The next challenge is existing sources, and this, as I just mentioned, is now an even greater challenge. Those countries who have now cancelled new plants will rely even more on their older, dirtier units. Article 8 also includes the requirement to establish and maintain an emission inventory, and this inventory is not just to provide a baseline for recording how well the emission reduction strategies are working, if prepared and analysed correctly, an inventory will inform the reduction strategy to ensure that it's technically feasible and cost effective. Emission inventories are theoretically simple. You take the amount of mercury in the coal, multiply it by the amount of coal burned, and then subtract the percentage of mercury, which is expected to be captured in the solid or liquid wastes. This can be done with a standard emission factor for coal, many of which are published within the UN inventory toolkit. However, if a country can produce data on the actual mercury content of the coals burned in their coal fleet, then this helps significantly. Unit by unit information on plant configuration, boiler type, pollution control system, so on, will also help produce a far more informative inventory. Mercury monitoring is expensive and technically challenging, and so not all countries are going to have plant coal-specific data in the very near future. However, even with the smallest amount of real data, it's possible for mercury emission inventory to be improved and to become a lot more useful. We therefore encourage countries to carry out some coal analysis before they finalise their emission inventory for the coal fleet, if they possibly can. Our project work benefited not only from significant amounts of data, but also from the application of the IPOC, a tool funded by Environment Canada and produced by Nixa Energy Associates. This tool is available free of charge to all, and it's incredibly useful for creating plant-specific emission estimates. We'll be hearing from Wojciech later, who will explain the IPOC that I'm showing here, explaining how coal and plant data can quickly be converted into emission estimates. And so to wind up my quick introduction, I'll leave you with this. COP26 is encouraging a move away from future coal. The existing coal fleets of many countries will now become necessary for baseload for longer than they may have previously, and some of these plants are already older and less efficient. Valid data is critical to informing the relevant cost-effective mercury reduction strategy. We encourage all countries to use coal and plant-specific data as much as possible. The challenge for Southeast Asia and other emerging economies is significant, but it's a challenge that is very much worth taking on. Thank you very much for your attention. Please do email me for more information. I'm very good at answering emails. Thank you.
Asif, you are on mute. Yes,
Hello.
I hear you.
Yeah. So thank you, Leslie. So now we will move on to the next presentation for this seminar. Our next speaker is Dr. Anton Purnomo. Anton currently serves as the director of the Basel and Stockholm Convention's Regional Center for Capacity Building and the Transfer of Technology for Southeast Asia, located in Indonesia. Aside from actively working in the subject of persistent organic pollutants and hazardous waste transboundaries movement, he also is involved in the project of mercury emissions inventory from coal-fired power plants in Indonesia since 2017. The regional center also assists the country in the inventory of mercury in medical measuring devices and developing the Minamata initial plants and executing of the Minamata specific international program project in collaboration with the Ministry of Health Indonesia, and provide capacity building for several medical facilities nearest with the ASGM artisanal scale gold mining locations. Dr. Anton, the floor is yours.
Thank you, Professor Asif, for the introduction. So, ladies and gentlemen, I would like to start my presentation with the next slide, please. With the Indonesia primary energy supply that we can see here that mostly the Indonesia energy supply is coming from oil, coal, and also gas. And then most of the oil goes to the transportation, but a big portion of the coal goes to produce the electricity. Of course, there is also other energy supply other than coal to produce electricity. But biggest portion is coming from coal, and then the electricity goes to the industry and also to the household. Next slide, please. So here is the Indonesian electricity development plan that is developed by the is revised every year, and it currently projecting to 10 years forecast. So with this annual growth of electricity demand reaching up to 6%, so currently country should also expand their power plant to provide the electricity demand. So here the government also forecast the transmission expansion, substation expansion, and also to reach up additional customer within this 10 years in front. So next slide, please. So here in the left side, there is a demand of electricity that is projected to grow almost double in 10 years. In 2019, the demand is only 245 terawatt hour, and this is projected will grow up to 433 terawatt hour in 2028. So and you can see in the right side the graphic that at the moment coal is contributing the highest percentage of this electricity in the country, which is at the moment is 65, and in the future in 2028, coal still projected to supply 55% of electricity in the country. So this is showing to us that in Indonesia, coal is extremely secure and cost-effective source of power. So it is current Indonesian economy and a vital factor for economic development. Next slide, please. At this moment, this is a coal production and use. So more than 70% of coal production are being exported abroad, and this also give the country revenue also. So the coal is still a big what you call it a source of the country's income at the moment. Next slide, please. So in the left side, there is a current Indonesian coal-fired power plant fleet. At the moment, we have 28,000 megawatt installed capacity, and mostly it's located in the Java region, because most people are located in the Java island. And in the right side, we can see that in the period of 2000 and until 2020, Indonesia's coal-fired power plant capacity increased almost fourfold, from 8.5 gigawatt to 34 gigawatt. This in this figure, we can see that in 2012 also the first supercritical technology is introduced, and the country is trying to use a better technology, which is ultra supercritical, starting in 2020, and it's growing for the new power plant that is being built now. Next slide, please. So the government is planning to build or to expand the power plant under current business plan totally amounting to 26,000 megawatt. And since in the Java area, there is no mining of coal, so there is a big what you call it power plant that is in Java. The government also building a power plant, but there is not a near the mining area. And however, in Java area, the government trying to build a new technology, which is the ultra supercritical coal plant in Indonesia. In here, we can see in the right side of any power plant, new power plant is now being constructed. Next slide, please. Okay, so although the government trying to build a new power plant with good technologies, but still, when we burn the coal, of course, mercury is still being released. And here in the left side, we also try to calculate the mercury released to air with using the toolkit level 2 from UNEP. And here the coal power plant are fall in the component 1, which is the extraction and use of fuel or energy sources, and together with the boiler power plant and also natural gas extraction, it contribute to the second to the highest of the mercury released to the air in Indonesia. Of course, it is after the mercury that is being released from the artisanal small-scale gold mining in Indonesia. And in the right side, it is shown also the figure that the estimation of mercury emission from Indonesia coal-fired power plant that was conducted in 2017. Next slide, please. Okay, so in 2019, the emission limits were tightened significantly, as shown in the table, and then the emission limit for particulate SOx, NOx are now in line with standard in other regions such as America, Europe. However, emission limit for mercury is still relaxed, which is about 0.03 milligram per normal meter cubic. And then the challenge here is that this current regulation, the government of Indonesia also asking the power plant to install the CHAMS for mercury to measure the mercury emission monitoring. So this has become a challenging task for some of the power plants because, of course, the CHAMS for mercury is expensive here. Okay, next slide, please. And then with the Article 8 of the convention, there is obligation to Indonesia to comply with the requirement to the new sources or new power plant and also existing sources or existing power plant. And as we see here, for the new sources, perhaps it doesn't become a big problem because usually in the new power plant, they already install all of call it emission control measurement, emission control reduction, etc., etc. But for existing source, it is also becoming very challenging for Indonesia because many of these plants are old and they are not designed and built with emission control as a major consideration. So actually, the UNEP also provide with the BAP guidance, but it does not provide the prescriptive instruction on how to control mercury to specific power plant. So, and that's why we are having this project. Perhaps in the next presentation, a colleague here will share with you how we which call it run the project and the planning the activity in Indonesia. Next slide, please. So with this, thank you so much for the time that is given to me. I will turn over back to you, Professor Asif. Thank you.
Thank you, Anton, and thank you for the very nice presentation. Our next speaker is Dr. Wojtek Jozowicz. Dr. Jozowicz has over 35 years of professional experience supporting the US government and other multinational and private clients and specializing in evaluation of air pollution control technologies. He has supported the coal partnership activities, providing engineering experience during the INC process for Minamata Convention and also later for the convention's implementation activities. He has authored over 100 presentations and publications, including the process optimization guidance for mercury emissions controls, and co-authored the PAT-BEP guidance for coal-fired power plants and industrial boilers. So, Dr. Jozowicz, over to you.
Thank you, Asif. Good morning, good evening, always, ladies and gentlemen. Good to be here. Today, I will briefly present mercury emission estimates with the IPOC. This presentation is jointly co-authored with Dr. Leslie Slaus of International Center for Sustainable Carbon. Next slide, please. As we all hear from fora like this and from media around us, existing plants are coming under increasing pressure to replace their production of electricity with cleaner ways, and countries are challenged to move away from coal. However, before this happens, mercury emissions from existing coal-fired power plants needs to be known for on a plant-by-plant basis to simplify the process for decision makers as to which plants should be operating, which plants should be upgraded, and perhaps which plants should be closed. This is where UNEP produced tools are very handy, and I will introduce two of them to you, specifically focusing on IPOC. IPOC stands for Interactive Process Optimization Guidance. This is the program that allows estimation of mercury emissions. And then I will close with an example of IPOC analysis. Next slide, please. So this is an example of a countrywide analysis. That this is the project that is supported by U.S. Department of State, and I would like to acknowledge their generous support here. So the cover page of this report, which is available online, shows that and discusses later. The project discusses that how we have analyzed the fleet. We have divided the fleet into specific groups of plants. So we have singled out plants that are nearing the end of their technical life, but are likely to be upgraded soon. Then significant group in Indonesia and throughout Southeast Asia are plants with so-called seawater FGD, when ocean water is used as a scrubbing media for sulfur dioxide and as a co-benefit mercury. This is important to investigate the means to reduce potential for increased mercury deposition when ocean water is returned to the ocean after being used at the plant. And then the final group were inefficient plants that were due for imminent refurbishment. Next slide, please. So two UNEP tools that are very useful for plant-by-plant analysis. The picture on the left-hand side presents cover page of process optimization guidance report that is available online from UNEP's website. And the right-hand side presents a screenshot of IPOC, of a computer program that has been built based on the POC. Next, please. So let me spend a few moments now presenting the POC for you, which was the initial tool developed for UNEP. The objective of this report was to present a compendium of control options for Mercury from coal-fired power plants. It was produced some time ago now, time flies, 2010, and it was produced with technological status at that time. It utilized global Mercury control experience. However, it significantly utilized the results of U.S. Department of Energy Mercury research program, which was peaking at mid and late 90s here in the U.S. and produced comprehensive results on Mercury control. The POC emphasized co-benefit approaches, meaning that it was focused on looking at how much mercury can be removed by air pollution control systems that haven't been specifically designed for mercury removal. And it was used as a platform for UNEP's PEP document development for coal-fired plants and industrial boilers. Next slide, please. So in the next step, after we had this POC document available, IPOC was developed with support from Environment Canada. It was developed in collaboration with Coal Partnership and has been largely coded according to the POC, to the written document. It utilizes proprietary calculation developed by Nick's associates, and it is I would call deceptively simple project. It has very intuitive interface that is covering complex set of equilibrium calculations. And the good news is that it is free from download from UNEP's website. It is available. I just checked it earlier today. Next slide, please. So this is schematic of how IPOC is organized. It looks at layers of emissions controls, and then by simple answers, yes or no, whether technology exists or not at a specific power plant, it presents users with options of mercury control, and these are little ellipses at the bottom of the slide. Next, please. So this is an example of how input to IPOC looks like. It has intuitive symbols for boilers, for heat, for air exchange, for electrostatic precipitator and stack. This slide specifically presents a basic, what I would call basic configuration, that there is only ESP, there is no sulfur dioxide control and no post-combustion control for oxides of nitrogen. Next slide, please. Importantly, IPOC is flexible as far as input of coal properties, which is particularly important with mercury when we're discussing mercury control. So the program itself has several coal categories coded in, but it also leaves the degree of freedom for user to code their own coal in. So user can input amount of sulfur, amount of chlorine in coal. These are very important for and affect mercury removal and behavior and removal in the system. And then, very importantly, user is allowed to enter their own mercury content of coal, which clearly affects the amount of mercury emissions. Next slide, please. So after inputting all this data, user is presented with estimates of emission of mercury emissions that you can see in the upper right corner of the slide. The program estimates stack emissions of mercury, and it is capable of speciation of mercury, meaning that it can estimate elemental mercury and oxidized mercury emissions, which are two main forms of mercury to be discussed at power plants. And also it estimates the outflows of mercury from furnace, which is the bottom ash, and from ESP, which is mercury that might have been captured on the fly ash. And these two outflows are presented by arrows getting down, pointing down from the furnace and from the ESP symbols. Next slide, please. So as we have very briefly discussed, mercury emissions from coal-fired units may be estimated with IPOC on a plant-by-plant basis, which is increasingly important nowadays to understand each power plant exactly how it operates with respect to mercury emissions. So by doing this, by analyzing plant by plant, IPOC may be very helpful in determining upgrades for plants, which plants would have priority. We have used IPOC analysis during numerous projects funded by UNEP and Department of State throughout the world. And IPOC tool is available as a free download from UNP website. Can I have next one? Okay, this is the final one. Thank you for listening, ladies and gentlemen, and I believe we'll have time at the end to answer some questions. Thank you.
Thank you, Wojtek, for the presentation. It's also good to see user-defined inputs being possible, especially things like ash content and sulfur content and chlorine content, which I believe are quite important. So now we have seen turning raw data into emissions. Our next presentation is about turning emissions data into a compliance strategy. And our speaker would be Leslie Sloss. Saiful, you may please start the presentation.
Hello again. Let's now look at how you can turn the data we've talked about into a compliance strategy. There are several ways of evaluating an inventory of coal fleet. We can look at current high emitters to identify sources of immediate concern, but this won't take into account that some of these plants may close quite soon. By combining all the data, we get a better look at what we call the emission intensity of each plant over its remaining operating lifetime. The mercury intensity is the amount of mercury emitted per gigawatt hour of electricity produced. So it therefore includes automatically coal mercury content, plant efficiency, and the presence of control technologies. So we took the emission intensity for each of the units in Indonesia and multiplied it by the remaining lifetime of each unit, assuming that each unit will run until it's 40 years old. This is an interactive spreadsheet. The Indonesian stakeholders are free to go back and change any or all of the assumptions we have made and to update the data every year accordingly. This graph only shows the top 30 plants out of 100 in terms of lifetime mercury emissions. The top 10 units here are predicted to emit over 30 tons of mercury before they close. This amounts to 40% of the 70 tons predicted to be emitted from the entire fleet before it closes. So targeting these top 10 out of 100 will clearly be far more cost effective than any blanket requirement for action across the whole fleet. Deal with these high emitters first and move on to the smaller units later. As Peter outlined earlier, there are many emission reduction options available, but each does have to be decided on a case-by-case basis by experts. Perhaps the most important thing is to reduce emissions of as many pollutants as you can in one go. In the graph I just showed, mercury emissions are shown in blue, but sulfur emissions are included as these little red dots. Some plants have both high emissions of sulfur and high emissions of mercury, and these plants would be excellent candidates for flue gas desulfurization systems, especially since Indonesia now has new emission limits for sulfur. But there are a few plants, such as Cirebon on the far left here, where the sulfur emissions are actually relatively low. Perhaps the sorbent approach makes more sense at this unit. Obviously, I'm not suggesting just control systems based only on this one graph, but I hope I'm showing how this level of data will help with the decision-making process. So based on the work so far, we've selected 3 high-emitting plants in Indonesia for further study. We're currently working with the US TDA and the Indonesian government and utilities to organise a meeting in Indonesia early next year to visit these plants, and we will be asking interested parties to join us in this work. We'll reach out via the coal partnership to ensure that anyone who wishes to be involved can certainly give their input. Now, I appreciate I've spoken very quickly about a complex project, so please do go to the Sustainable Carbon website for more data. There's a nice, slow 40-minute webinar on the subject on the US State Department project you can watch. There's in the middle there's the 90-page report you can download in its entirety explaining what we did and how we did it under the State Department project. And then on the right there's the 3-day workshop we held online in March this year that we recorded, and you can tune in and catch up on that if you like. Now finally, before I close, I want to stress that although country-specific data are extremely helpful, there's no reason why regions without this data can't make some clever analysis of the fleet to identify plants which are likely to be candidates for priority focus. This complex chart shown here is actually a simple way of ranking plants according to potential mercury emissions. Each line represents one coal-fired utility unit. For each unit, we are showing data on plant capacity, remaining lifetime fuel consumption, coal characteristics, and very many more variables that I've not shown here because there's no space. As much data as you have available. And what we've done is given each a score between 1 and 5, where 5, shaded red, is a warning, and 1 shaded green is not. Warnings include very simple factors such as coal consumption rate. Busier plants will emit more mercury. Lifetime of the plant. Younger plants get a high score as they will emit mercury for longer into the future, and so on. And these screenings can be added to give an overall score as shown in the brown column, and that provides your ranking. Although it's a crude approach, it gives stakeholders a very simple way to bring the focus of their concern directly to those plants where mercury emissions are likely to be greatest. And this means that any current or near-term plant retrofitting plan in the region can immediately bring mercury into the context of the discussion. So basically, the more data you have, the easier it is to make an informed decision. And expert guidance is always going to be required when you move into the producing the emission reduction strategy, and we're here to help. However, even without detailed data, you can produce a critical analysis of coal fleet based on simple plant information, and that can help you provide focus. Again, thank you so much to the State Department for the grant for this work, and thank you for listening.
Thank you, Leslie, again. So we have now looked at emissions generation, emissions data to compliance strategy. Our next talk is on compliance options. Our speaker is Dr. Peter Nelson. Emeritus Professor Peter Nelson has more than 40 years of experience in research on the assessment and control of air pollution or environmental issues associated with energy use, and has worked with industry, government, and community groups in addressing these issues. He has published in scientific literature over 300 peer-reviewed journal and conference papers, and in major commission reports for government and industry. He has been extremely involved in research and other activities on mercury and the Minamata Convention. He led the first comprehensive study of mercury emissions and releases in Australia, which informed the Australian government's response to this issue. Subsequently, he has also led the development of UNEP guidance on best available techniques and best available practices for controlling emissions from non-ferrous metal smelting. He has been a lead author of a briefing paper on mercury in non-ferrous mining and smelter sector, commissioned by the Global Mercury Partnership, and has been a member of the Global Expert Group preparing the 2013 and 2018 UN Global Mercury Assessments. He is also a co-lead of the UNEP partnership on mercury from coal combustion. So, Dr. Nelson.
And thank you for the opportunity to give a high-level description of BAT-BEP for the coal sector. What I would like to do in this talk is just describe the process by which the BAT-BEP was developed, discuss and describe some of the principles around BAT-BEP in the context of the Minamata Convention, and then quickly run through the various options for BAT-BEP for emissions from coal combustion. Next slide, please. So most of you will be familiar with the provisions of Article 8. So it concerns controlling and where feasible reducing emissions of mercury from point sources falling within the source categories listed in Annex D, and we'll come to the source categories in a minute. For new sources, each party is required to use BAT-BEP to control and to reduce and if possible, eliminate those sources. But for existing sources, each party needs to implement one or more of the measures, come up with a quantified goal, emission limit values. You can use BAT-BEP. You can use a multi-pollutant strategy, control strategy, or alternate measures. So they're very country specific in terms of the options that can be used. Next slide, please. So the coverage of Article 8, the 5 categories listed in Annex D of the Convention are coal-fired power plants and coal-fired industrial boilers separately. Smelting and roasting process used in the production of non-ferrous metals. That includes lead, zinc, copper, and industrial gold. Waste incineration facilities and cement clinker production facilities. So some time ago, UNEP began a process of developing or beginning to develop guidance for BAT-BEP for these industrial sectors. So next slide, please. The guidance on emissions within the convention produced 4 guidance documents in addition to the first one, which is the best available techniques and best environmental practices. They also produced support for parties in implementing measures for existing sources, in particular guidance on determining goals and setting emission limit values, guidance on criteria relating to the relevant sources, and guidance on the methodology on preparing inventories of emissions. So this work was conducted over about 3 years in advance of the first COP. And then the material that was presented was then accepted at the first COP and is now widely available. Next slide, please. The diplomatic conference that established the Minamata Convention also established a group of technical experts with 2 co-chairs made up of experts in pollution control and one or more of the source categories in Annex D. The groups drew heavily on the experience gained through the UNEP Global Mercury Partnership for these sectors. It invited the participation of experts from industry and civil society as observers, and it also invited input from other governments, intergovernmental organisations, industry and civil society organisations to assist it in completing its work. So it was a very consultative, large group. We split into 4 groups to look at the various emission sources or the industrial sectors. The 2 coal categories were combined into one. So the smaller scale furnaces were combined with large power plants in the guidance that was produced. Next slide, please. So the guidance includes some common sections which are relevant to all the source categories. There's an introduction, there's a description of how to select the best available techniques. It goes through common techniques that are used across all of the different industrial sectors, and it also describes monitoring approaches to measuring mercury, which can be a very challenging task in these industrial processes. It also includes chapters specific to each source category. So there's some common sections, but then there's a chapter for each of the source categories. And as I said, the 2 coal source categories are presented as a single chapter because a lot of the techniques overlap in that case. Next slide. So I think this is probably the key take-home point from my talk. And it describes the nature of the guidance. It's guidance. It's there to help parties. It's not mandatory, and it doesn't limit national discretion. So it's really there to be a useful resource for guiding parties on how to implement the convention. It doesn't define what is the best available technology. It provides information about a range of techniques to help parties make decisions, and the parties' decisions will need to take account of national circumstances. So a simple example of that is that some of these technologies require plentiful supply of water, and in some countries, in some locations, that is a challenge. The guidance reflects the knowledge and information available to the group at the time it was written, and of course, technologies will change, so the guidance should be a living document which improves and develops over time. So that's the key point. It's not mandatory, it doesn't limit national discretion, it doesn't define what is bad, but it just gives guidance on how to decide what makes sense in terms of national circumstances to use as BAT. Next slide. Okay, so here's the general issues around the coal sector for coal-fired power plants and coal-fired industrial boilers. The mercury emission control technologies are generally similar for all coal-fired boilers. So they have applications which are common across different types of coals. Mercury emissions from coal-fired combustion plants are affected by the mercury concentration and the speciation in the coal. By that I mean the mineral locations in which the mercury occurs within the coal and what other elements it's associated with. It's affected by the coal type and composition. In a previous talk, we heard how sulfur can have an impact on mercury emissions. It's affected by the type of combustion technology, and it's affected by the control efficiency of existing pollution control systems. So that's getting at this co-benefit effect. Next slide. So some of the examples of BAT-BEP are primary measures. By that, some examples of that are washing the coal to remove or to reduce the mercury content of the coal, refined methods to select and blend different types of coal to lower the mercury content of the coal that you're going to combust in the power station or the furnace. Then there are measures to reduce mercury emissions during combustion. So you can use, in some situations, fluidized bed boilers are used, and they tend to have beneficial effects on mercury emissions to air. And then mercury removal by co-benefit of conventional air pollution control systems. So a combination of selective catalytic reduction to reduce NOx, electrostatic precipitators to remove particles, and FGD to remove sulfur can also remove substantial amounts of the mercury, up to 95%, and they can result in concentrations of less than 1 microgram per cubic meter of mercury in the flue gas. A combination of those techniques with fabric filters replacing electrostatic precipitators can remove mercury up to 99% and result in a concentration of 0.5 micrograms per cubic meter of mercury in the flue gas. So existing air pollution control systems can have a beneficial effect on mercury as well. Next slide, please. And then there are dedicated mercury control technologies to specifically reduce mercury concentration. So activated carbon injection technology has been adopted and used very extensively in the United States. And those methods can achieve concentrations lower than 1 microgram per cubic meter. And in addition to those BAT technologies, general environmental efficiencies, both of the whole plant, of the air pollution control systems, environmentally sound management of the plant, and environmentally sound management of coal combustion residues can all result in improvements in the performance and reduction in mercury emissions. Next slide, please. In the process of producing the BAT-BEP document, the major issues raised in the public comment phase were questions about the performance levels of the technologies, the cross-media effects of control measures. So if you reduce mercury going into the atmosphere, additional or more of the mercury will end up in the solid and the liquid products, which will also need to be disposed of in an environmentally sound manner. The costs were raised, and the BAT-BEP document includes some discussion of the costs, but it's difficult to do that in a comprehensive way. Emerging techniques were also an issue that were raised, and there is some discussion of those emerging techniques. And then the challenge of mercury monitoring in these industrial situations was also raised in the public comments. And as a result, the document was modified to include some of those. Next slide. So that's a very high-level description of BAT-BEP approaches to coal in particular. The BAT-BEP, the guidance actually deals with all the sectors that are included in Annex D of the convention. The link there is to the site, which includes all the guidance information on the Mercury Convention, and a lot more detail is involved in that document. So thank you for your time and attention, and I'll be around for the questions.
Thank you, Dr. Nelson. Before we move to the next presentation, which would also be our last, I would like to remind the attendees to feel free to type the questions in the Q&A box for these or all the other presentations. So I would like to introduce our speaker for the last presentation, Dr. Itsuki Kuroda. Dr. Kuroda has worked for the Environmental Health Department in the Ministry of Environment, Japan since 2019, and she is also in charge of the Minamata Convention and SciChem, along with several other chemicals and waste-related matters. She currently serves as the Vice Chair of Implementation and Compliance Committee of the Minamata Convention. Before joining the Ministry of Environment Japan, she worked for the Japanese Food Condiment Company and Ministry of Foreign Affairs for 10 years in several countries, including Egypt, Jordan, UK, and the USA. She has received an MSc in Environmental Studies from University College London in the UK. Dr. Kuroda.
You see me and hear me well?
Yes.
Yes, dear participants from all over the world, good day. This is Suki Kuroda from Ministry of the Environment of Japan. Thank you very much for your time, and I sincerely hope everybody is doing well under these difficult circumstances. Next slide, please. So today I'd like to briefly introduce MOEJ's activities in Indonesia and Vietnam to support the reduction of mercury emission from coal-fired power plants. Please stop me if there's a problem in sound. Also, I'd like to touch upon our commitment to support developing countries' effort in mercury management, which is called MOEI Initiative. Next slide, please. So Minamata Convention on Mercury was adopted at the diplomatic conference held in Japan in 2013. And at this diplomatic conference, MOEJ introduced our intention to support developing countries in mercury management and also to disseminate their experiences and messages from Minamata. This initiative is called Moyai Initiative, which is officially launched in 2014. And since then, we have been proactively undertaking various activities in developing countries for global mercury management. If you are interested, our activities are introduced within COP4 INF document number 23, which is the compilation of submissions from parties on capacity building, technical assistance, and technology transfer. So one of our programs is designed to strengthen developing countries' mercury management measure by introducing Japan's know-how and technologies. And as a part of this program, we started feasibility studies in coal sector in Indonesia and Vietnam. Next slide, please. So firstly, I'd like to introduce our activities in Indonesia. As you all know, Indonesia hosts COP4 to the Minamata Convention and has shown strong leadership in global mercury management in recent years. Indonesia introduced this presidential regulation in 2019 to set out the national action plan in 4 areas indicated in this slide to reduce and eliminate mercury. As for energy area, the regulation set and tightened various emission standards from coal-fired power plants. So MOEJ conducted a study on technical needs on mercury management since 2014 and have identified challenges they are facing. One of them is while majority of coal-fired power plants meet emission standards of mercury, as Anton also mentioned in the previous presentation, the total amount of mercury emission is high. Also, to meet the tightened emission standards on certain pollutants has been difficult. Therefore, multi-pollutant control measure is necessary. One of the other challenges is to install continuous emission monitoring system on mercury. Next slide, please. So based on feasibility study, MOEJ conducted additional studies and workshop in 2019 and 2020. And we analyzed the mercury contents of some coals produced in Indonesia and identified applicable emission reduction techniques. And then conducted interviews with relevant stakeholders, including government, industry, and academia, and held face-to-face workshop in 2020 in Jakarta. And we identified various characteristics in each coal-fired power plant. This means technologies each power plant needs varies based on their different characteristics. Therefore, in order to introduce the mercury countermeasure technologies, it is important to propose specific countermeasure technologies that are suitable for each plant. We shared the outcome with the National Electric Company PLN and introduced so-called co-benefit technologies owned by Japanese company, which can achieve both mercury and SO2 reduction in 2020. Next slide, please. And in this fiscal year, based on the previous studies and feedbacks from the workshops, we will conduct a more detailed study to examine the applicability of those technologies in selected coal-fired power plants. Also, results of feasibility study will be shared with various electric companies in online workshop. Next slide, please. So next, I'd like to introduce our activities in Vietnam. And as for Vietnam, mercury emission standards have not yet been set for coal-fired power plants, and mercury management has not yet been progressed in business sector. Therefore, Ministry of Industry and Trade which is the focal point of the Minamata Convention in Vietnam, has an urgent need to develop emission standards, and they requested assistance from Japan using Moyai Initiative scheme. So there are three cooperation areas, namely sharing the experiences related to the development of Japan's emission standards for mercury. And secondly, support for developing mercury emission inventory and material flow analysis. And lastly, understanding the mass balance of mercury in coal-fired power plants. Next slide. As a first step, MOEJ conducted surveys in mercury emissions by taking samples of flue gas from selected power plants and analyzed mercury emission in Vietnam to understand the current situation in 2020. In a positive note, mercury was not really detected from flue gas, and because of it, the mercury mass balance in power plants could not be evaluated. And in order for us to be able to examine the mass balance, it is necessary to conduct further surveys on not only flue gas, but also the type of coal that are used, ash and wastewater, to understand the more accurate status. Next slide, please. Therefore, in this fiscal year, we will conduct surveys on not only flue gas, but various items in the selected power plant. We will also study purchasing pattern of coals, frequency of analysis, management methods of coal, and current status of complying with the emission in order for us to identify suitable technologies for mercury management. We will share the result at the workshop. Yes, this is it. So it's rather in rush, but back to you, Asif, and I'm ready to answer that question. Thank you.
Thank you very much, Itsuki. And thank you all the panelists for their presentation and contributions. Now the floor is open for Q&A. At the moment, we don't have a question, but by the time the audience read, we can probably start the discussions already. So there was a discussion topic, and which is very current, is the impacts of the decisions of the climate conference in COP26. And this is open to all panelists. Please feel free to unmute and speak whatever you have. So is it, one is more technical, is it related to new power plants or all coal use? And do we expect an absolute decrease in coal use or mercury emissions, or only the rate of increase, or is it going to decline?
I can answer that question if you like, Asif. What we're seeing is this agreement that there won't be any new coal. That does not mean we are peak coal yet, because some countries have already committed to finishing building the new plants that they have planned. So we will see coal continue to go up. Some countries have peaked coal. Europe has probably peaked coal. The USA has probably peaked in coal, and other countries should peak coal within the next 10 years. There is also the issue that although they may not build any new plants, they may call upon older units more for baseline because they don't have any new capacity coming on board that's baseload. So we may see some countries actually switching on some plants that they have closed down. This has happened in the UK to keep the lights on in the last year. So even with no new coal build, mercury emissions could still increase in the short term. However, in the long term, they will peak and they will come down. And also, as new legislation comes in, not just for mercury, but for SOx and NOx, such as in Indonesia, we will see the installation of FGD and other BATBEP technologies, and that should help decouple the mercury emissions from any change in coal use. So although coal use may stay, may start to stabilize and come down, hopefully we will see mercury emissions coming down much faster because of the availability of these controls.
Thank you. Any other inputs?
If I may jump in as Minamata Secretary, and I think thank you, Asif. This is a very important question, very timely question. How what are the relationship between the UNFCCC and the Minamata Convention? And I note that in the Glasgow Climate Pact, it's the country is committed to phasing down of unabated coal power plants, and of course there are many pros and cons and so on and so forth. But perhaps I think the the abatement technologies for climate change will greatly contribute to the mercury reduction as well. And also I wanted to highlight on the last discussion on the technology mechanism, and perhaps one question I would like to ask you is what initiative we will need to disseminate, transfer technologies for mercury reduction in coal. And I note that in Anton's presentation, he said about the economics of the energy source, and the coal is used because it is cheap. So how should the technology can be disseminated, how these should be financed? This question may be a bit too big, but I've stopped here. Thank you.
Anton, do you want to answer that from your experience?
That's a very hard question, actually. But yes, I mean, indeed, at the moment, this country are still using a coal as a main source of energy, something like that. But of course, the government is trying also to what you call it to reduce what you call it the impact on the emission that generated from coal, something like that, using the new renewable fuel, etc., etc. But it is really hard for me as to answer Isaku question. Perhaps any other panelists here can help me. In addition, actually, the in the newest business plan of the government, actually, it is also mentioned that this country also trying to develop a geothermal power plant to reduce the dependence on the coal, and also there is mentioning about the nuclear power plant, but it's still far away from now. I mean, at the moment, coal still is the most feasible source of energy at the moment. Anyway, that's why we are here trying to help the private sector and also the government in order to minimize or reduce at least the high emission of this coal power plant in Indonesia. Back to you, Dr. Professor Asif.
Thank you. Okay, Leslie has a comment. Yeah.
If the question, Isaku, was about funding and how to actually get the mercury control happening, that is a very important and a very challenging question, because the coal sector is now seen as something that is going away, and therefore nobody's going to fund. They're not going to fund new coal, but neither are they happy to fund technologies for a coal-fired plant that has a limited timeline remaining. And so it falls to the governments or the utilities themselves to cover this cost. And this cost is huge and is not necessarily going to be recovered over the remaining lifetime of the plant. So it's a huge challenge, and it's suddenly gotten worse because coal is now thought of as even dirtier and thought of as going away. And so it's fantastic to see the initiatives that Suki has talked about, where we're talking about other governments that have experience in Japan has their mercury emissions completely under control. They have some of the best technologies in the world for getting mercury right down to practically zero. And so they're ideal to go and work with Indonesia to show them what works, to tell them how they got it to work, and hopefully to kind of get their experts and their commercial companies to move into Indonesia with a cost taken into account sometimes, so that okay, these companies are still making a bit of profit and covering their cost, but they are hoping to keep the costs down and make everything as affordable as they can to these emerging economies. And I'm very grateful to Suki for her information, and I hope to follow that project very closely.
Thank you, Leslie. There is a question in the chat box. So if we do, Claudia didn't have, if we do a plant-by-plant analysis of current plants and those coming on stream, how many would be moving in the right direction in terms of what is required for mercury, and who are the leaders internationally?
I think I maybe answered that. The leaders internationally are countries such as Japan, and also I see Wojciech waving his hand. Has had a lot of experience in the USA. Wojciech?
Yeah, thank you. Well, I wanted to add that to relate to Peter's presentation when he mentioned bad BEP, and then took a point to stress that bad BEP is only a menu of options. There is no mandatory requirements on anybody to do anything. So it's the role of individual parties and countries to implement what makes sense at their countries. You know, like what we currently seeing, that some countries decided to switch all coal-fired power plants out, but other countries are still building new coal-fired power plants. So it really depends on what makes sense for everybody. And as far as who is the leader, well, certainly Japan, US, Europe, there is a lot of technology know-how, but it's a huge role for fora like this to disseminate the information and to make it available to people, so that everybody by listening can pick what is of interest to them and implement accordingly. Thank you.
Any other comment? Peter.
Just a comment, I guess, on some work that we have recently had funded by the Global Environment Facility, which is really to look at this question of, in the context of the Paris commitments and now the Glasgow updates, what does that mean for mercury into the future? So our plan for that project is to use a baseline of the global mercury assessment numbers and then try and predict what will happen in 2030 and 2050 with various scenarios of changing coal use. So that's a project which will come at that question of what's the impact of reduction in use of coal on mercury. And I guess the second issue that I'd like to raise is that the convention doesn't only look at emissions of coal. So we start to then have to focus on releases as well. So, you know, if we get better and better at reducing what's going into the atmosphere, all of it is in the residues that are captured either in precipitators or scrubbers, and what then happens to those it then becomes an important issue. And I know the Asaku has been working on releases with another expert group, and I think that's very important work to see what we describe as a release, what is, you know, a secure storage for these types of byproducts of the combustion process and other industrial processes.
There is a follow-up question. Who might, maybe a single line answer, who might be the leaders in the developing world?
That's a very tough question, and I would say the leaders are groups who take the most initiative, because it requires initiative on a country level and societal level to implement changes promoted by Minamata Convention.
I think Itsuki, you had a comment.
Yes, so I mentioned Indonesia as showing strong leadership since they host COP4, and also as I mentioned in the presentation that they introduced this presidential regulation in 2019 to eliminate the mercury, reduce and eliminate mercury, and since we have enabling framework, which is MOYAI initiative, we conducted the feasibility studies to see what kind of technology and know-how we can provide based on their needs mentioned within the regulation, presidential regulation. So I would say Indonesia must have had a strong leadership in the developing world. And apparently from all the presentations shows that lots of parties, lots of stakeholders are interested in working within the Indonesia. And also, as previously mentioned, not only emission flue gas, but also items such as what kind of coals are used, and also ash, wastewater, various items has to be analyzed to really understand what is the current status to decide what's the best course of action to take. So that's what we have been doing in Indonesia and Vietnam. And yes, it was interesting that I had all the inputs today. And if we can seek kind of demarcation of each work, and if we can collaborate some sort of work to work in one country, because there are lots of activities happening by various parties in one country or one region, then seeking the demarcation process, it must be also important things to do.
Thank you. Before we move to next question, Isaku, we have 4 minutes of designated time. Are we allowed to extend 5 minutes or so, or is it can discuss for a few more minutes?
Well, if for the panelists are fine, I think we can extend a little bit. Thank you.
Looks like they are fine. So the next question is, actually there are 2 questions and both on Indonesia. So the first is, how are the air pollution control residues handled in Indonesia? And I would like to add that, you have been involved in the work in Indonesia, and how did you got all the stakeholders on board? Like, what was that made it click? And what is the current situation? Thank you. Itsuki?
Sorry, struggle to unmute. So the technical issue, I might need to bring our consultant, Mr. Sakimoto, if he can answer, who actually had conducted a feasibility study in Indonesia. For some reason, I cannot see the question.
It's in the chat box. How are the air pollution residues handled in Indonesia?
Mr. Sakimoto, if you could answer.
Hi, Suki. This is Shariful from the Minamata Secretariat. We can see that Mr. Sakimoto is unmuted, but we cannot hear him right now. Maybe some technical glitch from his side.
While waiting for Mr. Sakimoto, perhaps in the USDOS project in project, did you see any practice in Indonesia?
Anton can cover this point.
Oh, Anton, yes.
Thank you so much. So while waiting Sakimoto-san to what you got it, fixing the problem. So in the previous in the residues from air pollution and that is captured by what you call it ESP, so-called fly ash, something like that. Actually, is considered as a hazardous waste, and it is being treated very secure, something like that. However, the cost implication is also very high, and then it also resulting to certain what you call it power plant that do not have their facility surrounding nearby in their facility, so they just put it in one place and then just there, something like that. And then after several years, many years, it become very huge, like a mountainous small mountain like that. So that's why with a lot of with a very long what you call it negotiation between the power plant and also the Ministry of Environment, now the fly ash residue is being treated as a specific so-called specific waste. It can be now being utilized for other purposes, something like that. For example, like making a brick or for other purposes, just uh, to uh, to make practices rather than just throwing away in certain power plant, for example, like Ombilin, something like that. So now it is the communication between the Ministry of Environment and the power plant are now much better. And then, of course, for some power plant in Java Island, where they can what you call it treated the fly ash easily, for example, to the cement company or to specific a hazardous waste company treatment. So it is no problem. But for the problem is appearing in the power plant that do not have a treatment facility nearby their location. Thank you. Back to you, Professor Asif.
Thank you, Anton. Any other comment? So, okay, if I were to ask some more question on the project in Indonesia. So, you know, in 2019, the government announced and already like a lot of action has taken place and is still going on. So in your interactions with industry, academia, and the government, what was the like buy-in message or buy-in messages that, you know, brought everyone on board very quickly? Itsuki or Anton, you have, yeah.
Yeah, so we paid a visit to various stakeholders in Indonesia, but to share the message is kind of difficult because it's not that we ask the same question to various stakeholders. For example, the government, since the presidential regulations set and tighten the emission standards, we paid visit to those governmental institutions that are responsible for implementing the standards. For example, Ministry of Environment and Forestry from the policy perspective, as well as Ministry of Energy and Mineral Resource for industry management perspective. So, and then we have also visited industry stakeholder to interview the electricity company to learn their methods and the frequency of monitoring, how they are complying certain standards, future investment plans, and their needs and challenges. And then academia, we visited the institution that analyzed the mercury emission using UNEP toolkit, as well as the institution that has conducted studies on emission status through UNEP project. So each stakeholders are playing different roles, and so our questions also varies based on what kind of role they are playing for the mercury management. Yes, that's and how they are implementing what they have to do right now is what we are going to do for coming feasibility studies. Thank you.
Thank you. Any other comment?
I would like to add uh, uh, some share from me myself. So reading on the what you call it business plan from the government yeah, lately. So the government of Indonesia also trying to replace the old power plant that are inefficient and consuming a lot of what you call it coal just to produce a small amount of electricity with new power plant, although still in coal power plant, but with this new technology and then air pollution control, good air pollution control. So within the same coal that the country burn, of course, it will produce much higher of electricity. So I guess this is one of what you call it good initiative from Indonesia that is also important to be shared. And I guess initiative like this, I mean, what you call it, sharing between all of stakeholder all around the world is also very important in order to share expertise or share experience between countries to countries in order to expedite the implementation of the Minamata Convention. Thank you.
Thank you, Anton. There is one question in the chat box. It came privately. So the question is, if a power plant implements a combination of SCR plus fabric filter plus flue gas desulfurization, does it need to continue with coal washing? And the follow-up comment is that coal washing might even cause mercury contamination locally. So if a plant were to use all these technologies, do they still need to do coal washing? Leslie, or
I was going to say, I was going to bring Wojciech in. Changing the coal used at a coal plant can bring challenges because the coal mill and the boiler has been designed for a specific coal. So if you change the coal that you're putting in there, you may come up with technical issues. Yes, coal washing can cause a lot of problems with waste materials and mortuary wastes and liquids. And so yes, moving to control technologies where everything ends up in an ash that you can use in cement concrete makes far more sense. However, I'll hand over to Wojciech, who will answer better.
Coal washing is of course very beneficial for plant operation. It reduces the impact of ash, which may be of particular importance in countries that tend to fire high ash content coals. However, it creates additional dimension of complexity in that it creates waste from coal washing, which then needs to be addressed to live the spirit of Minamata, to look at the multimedia effects of coal use. If power plant has implemented whole suite of controls, meaning electrostatic precipitator and wet flue gas desulfurization preceded by SCR on the boiler, then theoretically it can handle coal with high ash content without coal washing. However, additional steps will need to be taken. For example, for SCR, the pitch of catalyst would need to be increased to prevent plugging. So very delicate balance. And again, I would like to get to what Peter said, but each party needs to decide what makes sense for them. There are many ways to skin the problem. Thank you.
Thank you. Any other comment? We can almost close the discussion. There was one question in the discussion point that seawater FGD may release mercury to the sea. So in that case, what is the best practice?
That's what we're trying. If you recall presentation, we have specifically carved out the group of coal-fired units in Indonesia that have seawater FGD to understand it better. What I can say and what I can refer the person or the group who asked the question, look at UNEP's website and try to find the UNEP report for Thailand. There you will find information when measurements were taken at one of units with seawater FGD, and you will see that unfortunately mercury content in the bay near where intakes are and when outflows are has been increased. So this is the worry, because we need to remember that seawater FGD was originally designed for capturing of sulfur dioxide, which is an acid gas, and the concept relied on using alkalinity in seawater to neutralize sulfur dioxide in the flue gas. And then seawater scrubbers have this step that before wastewater is released back to the ocean, there is so-called aeration to convert sulfides into sulfates, meaning for them to be more compatible with ocean environment. However, at that time, when seawater scrubbers were developed, people were not thinking very hard about what happens to mercury. We have now learned that wet FGD is excellent tool for capturing mercury, which is great, but in case when we are pumping waste directly into the ocean, that may not be so good. So it needs scrutiny to understand very well what is happening in seawater FGD. Thank you.
Thank you. While handing over back to the convention, I have a question to the secretariat, let's say. So given the actions that were taken in the COP26 regarding coal use, do you think that parties will be more motivated to work towards the Minamata Convention mercury reduction, or will they think, it's already taken care of in a way? Do you have any impression on that?
Thank you. Well, that's a difficult question to answer. But what we believe in is that there's always a synergy between the climate actions and mercury actions. Of course, there may be some trade-offs, but in many cases it is a synergy. And certainly the Glasgow Climate Pact to phasing down the unabated coal use is certainly a benefit for Minamata Convention, and we see much opportunity in liaising with UNFCCC in terms of the emission inventory, GHG and mercury, and also stock take and so on and so forth. So we very much look forward to them. Thank you.
Thank you, Aisaku. So thank you, everyone. I would like to hand over back to Aisaku and Joy for the closing remarks.
Thank you, Asik. Thank you, all the panelists. This is extremely interesting session. And in closing, I cannot resist you using saying very briefly three things. One is about a partnership, and as Leslie mentioned, the global market partnership is working very closely with all the industry partners. And if you have any quick questions, as we received in the chat box today, I think it is very good idea to use this partnership to deal with these technical questions. The second thing is that we very much look forward to hearing from parties in their national reporting on what measures they have taken on pursuant to Article 8, which includes the inventory and BAT-PEP. Of course, the BAT-PEP guidance document itself is not a mandatory document, but they have a mandatory obligation to take measures that includes BAT-PEP. So it is mandatory. So thirdly, I look forward to the ICMGP science the workshop, and this Minamata online session is related to the workshop on coal at ICMGP, and since this is about science, I think they are very good scientific question about where does mercury go in seawater FGD or fly ash coal, and coal washing, bottom ash, and so and when they are used in cement, then where does it go, and so on and so forth. So we very much look forward to the science, mercury science, to inform the policy making decisions. So having said this, I would like to turn to Joy for your closing remarks.
No, thank you very much, Esako, and thank you very much to all the panelists and also to Leslie for submitting that proposal on the workshops, and just listening to all the exciting work that has been done and where we need to go to, and still taking the Glasgow COP into consideration on climate change. There's a lot still that we have to do. And so, and I think mercury, the mercury in coal is definitely something that we need to put a lot more attention, focus a lot more attention on it. And Leslie, I think we just also need to discuss it probably more in terms of the virtual conference. I know you're having the workshop, but I just think that this was so excellent. Really, the information that you shared and the questions that came out, and the responses also, it was really all excellent and very much linked to what Esako was saying, the mercury science behind coal, mercury emissions from coal. And so really, once again, thank you very much from everyone. And also just, it was a really global presentation. So thank you very much, a global webinar, and that is definitely what we're seeking for. So well done. Thanks. Over to you,
Thank you.
Eisaku.
No need from me. Just thank you and goodbye. Thank you very much.
Thanks, everyone. Goodbye.
Bye.
Bye-bye.